Hello friends, my name is Abhishek Srivastava and please watch this video till the end. Please subscribe me and press the bell icon. Today we are going to do combination of resistance, formula for series and parallel, their derivation. It is of subject physics of class 10. So we are going to start. First we are going to do series. So I am writing here series. Suppose there are three resistances R1, R2 and R3, and they are being connected in the circuit like this. This is our circuit which is connected to a battery of V volt. I current is flowing through this. This is R1, this is R2, this is R3. And now here, according to Ohm's law, the voltage will be V is equal to IR. R is the equivalent resistance. This is our first equation. Then next is the voltages. We can suppose the voltage V1, here V2, and across R3 it is V3, the voltage. So V1 voltage will be I times R1, this is our second equation. V2 voltage equal to I times R2, this is our third equation. And V3 voltage will be I times R3, this is our fourth equation. Now the voltage will be the sum of the individual voltages. So V is equal to V1 plus V2 plus V3. Substituting the values of V1, V2, V3 and V from equation 1, 2, 3, 4, we get I times R equivalent equal to I times R1 plus I times R2 plus I times R3. So we can simplify. I times R equivalent equal to I, we can take common, R1 plus R2 plus R3. So this is our expression. I and I gets cancelled. So we can write the final expression R equivalent equal to R1 plus R2 plus R3. So our expression becomes R equivalent equal to R1 plus R2 plus R3. It is simply the sum of all the resistances. So the equivalent resistance in series combination is equal to the sum of the individual resistances. So now we can understand it once more. This is our series combination of resistances. This is our circuit. R1, R2, R3 are connected in series. In series, the current I remains same, whereas the voltage is different. The voltage across the battery is V. The voltage across R1 resistor is V1. Across R2 resistor is V2. Across R3 resistor is V3. So we can write the equation according to Ohm's law. V is equal to I into R equivalent. R equivalent is the equivalent resistance. V1 equal to I times R1. V2 equal to I times R2 and V3 equal to I times R3. Then our voltage will be the sum of the individual voltages. So V is equal to V1 plus V2 plus V3. So I into R equivalent is equal to I times R1 plus I times R2 plus I times R3. I times R equivalent is equal to, taking I common, here it is R1 plus R2 plus R3. I and I gets cancelled. So R equivalent equal to R1 plus R2 plus R3. So our equivalent resistance is equal to the sum of the individual resistances R1, R2, R3. This is our formula for the series combination of resistances. I think you all have understood this. Now we are going to proceed to find the formula for the parallel combination of resistances. So I am rubbing the board. Parallel combination of resistances. So it is parallel. This is our formula. This is our resistance. It is like this. This is our voltage across this. Across this the voltage is V. Resistances are R1, R2, R3. Here is the I current that is flowing. Here the current divides into I1, I2 and I3. So this is our circuit. Here in parallel combination, voltage always remains same, whereas the current is different. So here the voltage is same. So we can write I V is equal to I times R equivalent. So from this we can write I is equal to V upon R equivalent. This is our first equation. Similarly, from the Ohm's law we can write the equation for I1. I1 voltage will be same, so it is V upon the respective resistance, that is R1. This is our second equation. I2 equal to V upon R2. This is our third equation. I3 equal to V upon R3. This is our fourth equation. So the equation becomes I is equal to I1 plus I2 plus I3. Here at the junction, you can say node A. At node A, the current that was going into the junction is I, which is equal to the current that is being divided among these resistances, that is I1 plus I2 plus I3. Substituting the values of I, I1, I2, I3 from the equation 1, 2, 3, 4, we get V upon R equivalent equal to V upon R1 plus V upon R2 plus V upon R3. So taking common V upon R equivalent equal to V taking common 1 upon R1 plus 1 upon R2 plus 1 upon R3. So V and V gets cancelled. So we can write it here. I can write the equation here. So it will be 1 upon R equal to 1 R equivalent equal to 1 upon R1 plus 1 upon R2 plus 1 upon R3. So this is our formula. So this is our circuit. This is voltage. R1, R2, R3 are the resistances. I1, I2, I3 is the current that is flowing. I is the total current that is flowing through this. So according to Ohm's law, V is equal to I times R equivalent. We can arrange it and write it like this. I is equal to V upon R equivalent. This is our first equation. Similarly, we can write for I1 equal to V upon R1. I2 equal to V upon R2, I3 equal to V upon R3. So our equations will be V upon R equivalent equal to V upon R1 plus V upon R2 plus V upon R3. So we can take common V. V upon R equivalent equal to V, taking common 1 upon R1 plus 1 upon R2 plus 1 upon R3. Now V and V get cancelled, they are of same sign on left hand side and right hand side. So we get 1 upon R equivalent equal to 1 upon R1 plus 1 upon R2 plus 1 upon R3. This is our equation or the formula to find the equivalent resistance for the parallel combination of resistances. This is the reciprocal of the equivalent resistance is equal to the sum of the reciprocal of the individual resistances connected in the circuit. So this is our formula for the parallel combination of resistances. So I think you all have understood, might have understood this. So please watch this video till the end, subscribe me and press the bell icon. Thank you.